process of making a homemade PCB. So what is a PCB? It's a printed circuit board that a board with tracks of conductive elements like copper and gold on a sheet of insulated substance. It looks like one of this. So we have some examples here we can show you. And PCB is so it's used to have electronic components can be soldered right onto the board. Therefore, it gives us a platform for the components and secure and form connections. So here's a little history. The concept of a board with electronic component on it has been around for some time, but it wasn't until 1936 this Paul Eisler have introduced PCB in England as a radio set, as a part of a radio set. And then it come to World War II when U.S. have used this technology to create, to make a large scale of military radios.
So before the PCB became popular, there were a few types of constructions. One was the point-to-point construction, where you would take an electronic component and solder it to the end of another, and thereby creating this honeycomb of a structure that would then be shoved into a cavity of the device. This here is a radio, and uses very little wires, as you can see, but a lot of components. Diagnosing a problem in that would be a nightmare, really. Another type was the turret board. This would be a wooden platform with electronic conductive leads coming out of it, and then you would literally tie or solder the leads of the electronic components to it. And then, as you can see here, one would be tied to a pole and another would be tied to the same pole, and that's how you get end-to-end connectivity. This is more sturdier than that honeycomb point-to-point construction, but again, it doesn't offer the same compact nature that a PCB does. And it requires more space to have the same amount of components that you would otherwise be able to fit with the point-to-point constructions. Therefore, when the PCB did come about, there were many benefits: easy diagnostics of components that blew out, and therefore easy replacements. You just take it out, put one back in, and because the wires are already, or the tracks are already on the board, you just need to take out that particular component and place it back in. Of course, it was sturdy and compact, and because of the board nature, circuits could be divided into modules, much like these robots, where the modules are on different boards and put together. But the biggest advantage of a PCB is that it can be systemized to produce automatically and have the components solder onto it as well. So basically, you just draw schematics on the computer, give it to a machine. It makes the board, and then solders the components onto it, and out comes a product that is ready to be used without any human intervention. But for this presentation, we'll be focusing on more amateur PCB production. And the common types are single-sided, double-sided, and again in combination with lead components, sort of like these ones, where the component actually goes through the board onto the other side, and surface-mounted components, which I guess Jimmy has on his robot, the chip, where the leads don't go through the board itself, but rather it's connected to connections on top of it. But if we have single-sided, why do we need double-sided boards? The answer to that is the PCB wire tracks, like these, run along on an X and Y coordinate, so they're 2D. But that's fine for boards like these, where you have only a small number of components on it, so you can get that connection. But as the complexity rises, so when you get to more connections and more leads, then you might not be able to connect them all together without crossing over each other. And let me give you an example of that. Here is a component. There's a chip in the middle connected to a component up there, which is fine. But what if we have another component Now we get some sort of short circuit going on in those 3 leads or the pins over there of the chip, which is no good. The solution to that would be either move that second component underneath or in between the 2 leads of the first component. But what if the chip was bigger? What if it had more leads in it? You can't just keep nesting the components in. There must be a better solution, and that's where the double-sided comes in. What if we can dip through onto the other side, cross over safely, and come back up and continue the connection? That's what the other side allows us to do, is to go down, cross over, and come back up. Now moving on, there are 2 types of processes in PCB manufacturing. There's the subtractive process and the additive. In the additive process, copper is selectively placed onto a bare substrate. This is called the copper electroplating. It's an advanced technique, needs high voltage and a big warehouse where you can store all this, and a lot of knowns. And in the past it happened like this. No, literally, that's what the Wikipedia picture is. Additive process is useful for when you're making multi-layer boards. These ones only have 2 sides to them. Well, in advanced processing, you can actually have multiple of these double-sided sandwiched together, linked with vias where all the connection goes, and that makes it a really advanced board sandwiched together and makes it really compact. And it's extremely thin layers sandwiched together, used for making compact PCBs that require a lot of connections. The subtractive process we'll explore, because that's what we can do in at home or whatever in your shops, is when you selectively remove the copper from a copper board with a copper pre-applied. It's a cheaper process, and it involves 3 steps: marking the areas you want to keep, etching, which is removing the areas you don't want to keep, and then drilling for the holes, which either connect the 2 sides, which are called vias, or for the pin to be held together. Let's get the etching over with. This is the second process, but let's get it over first. There are two ways that you can do this. Is either through chemical or milling. In chemical etching, you use something etchant to react with the copper and pull it away. The exposed copper. The most common technique is the ferric chloride technique, where the exposed copper is pulled away by the ferric chloride. And if you're interested in chemistry, you have the ferric chloride or iron 3 chloride combined with the copper that creates a redox reaction, which gives off ferrous chloride and cuprous chloride. Then another reaction happens, which is the ferric chloride and the cuprous chloride, and they react to form the ferrous chloride and the copper 2 chloride. And this is why the etchant runs out so fast, because it's doing 2 reactions, and the iron and the chloride and the iron, the iron and chloride are used up twice as fast when removing iron, and this is why the etchant becomes so useless so fast. The milling etching process uses a CNC mill to literally drill away the unwanted copper. It's probably the method that requires the least amount of labor, since you just get a layout, give it to the machine, and drills away. But the accuracy again depends on those stepper motors and how accurate it is. So there's a homemade contraption, and he actually managed to get a really good result with that tiny board, and he actually managed to get really good layout there. But it's not always the case with this. So back to step 1. The hardest part in making your homemade PCBs are actually marking the areas you want to keep. So our purpose is simple: stop the etchant, the ferric chloride from reacting with the copper. So we cover the copper with something that doesn't react with the etchant. Usually it's either glass, plastic, or oil-based compounds. And various methods exist to actually do this, to hide the copper that you want to save, either through silk screening, photographic exposures, ultraviolet light to photosensitive materials that harden where the light hits, and they wash away where it doesn't. And then there's the toner transfer, or the toner refuse, or the toner whatever. It has too many names, but the general idea is that you get the toner onto the board, and Anna will explain.
So what we did is doing the toner transfer, which is transferring the laser printed toner from the paper onto the cover, right? So it's not as easy as you think.